Welcome. In this video, we will learn about vectors. Vectors are mathematical objects that are used to describe quantities that have both a direction and a magnitude. For example, we can imagine a car traveling east at 45 miles per hour. East is the direction and 45 miles per hour is the magnitude. We could represent this with an arrow pointed east, where the length of this arrow can be thought of as 45 miles per hour. Imagine a sled being pulled where the rope is at an angle of 30 degrees to horizontal. If a force of 200 newtons is being applied to the rope, then this can be represented as a vector at an angle of 30 degrees with a magnitude or a length of 200 newtons. Here's a more algebraic way of representing a vector. We write it as an ordered pair, but instead of using parentheses, we use these angle brackets. We have an x component of 3 and a y component of -1. That means we go 3 in the x direction and down 1 in the y direction, and so our vector looks something like this. There's nothing special in this example about where the vector starts. We could start the vector at any point. We could start it, say, here, and we still just go 3 in the x direction and down 1 in the y direction. Or we could have the same sort of a vector over here. These three vectors are all the same. They're all the vector 3, -1. The vector that starts at the origin is called a position vector. We could also have three-dimensional vectors. Let's think of the vector 3, -2, 6, and since this is in 3 dimensions, we'll use GeoGebra to visualize. To graph a vector in GeoGebra, we type vector, and then we type the point, 3, -2, 6. This vector goes 3 in the x direction, -2 in the y direction, and then up 6 in the z direction. There are two basic ways of combining vectors, and we'll see other more interesting ways of combining vectors later. For vector addition, we simply add the components together. For example, if we have the vector 3, -2, 0, plus the vector 5, 2, -4, then we add the x, y, and z components together. 3 plus 5 is 8, -2 plus 2 is 0, and 0 plus -4, -4. That is vector addition. Simply add independently the x, y, and z components. For scalar multiplication, we could have an example such as 5 times the vector 3, 1, -2. Here we multiply each of the components by the scalar 5. The result of this is the vector 15, 5, -10. This is scalar multiplication. All of the components are scaled by the same multiple. Let's talk about some different notation and terminology for vectors. A standard way of representing vectors is to write the vector name, and we either write the vector name in bold or we write a small arrow over top of the vector. Typically, this angle notation is used, although some textbooks may use parentheses or even brackets instead of these angle brackets. We could have a two-dimensional vector where there's both a x component and a y component, or a three-dimensional vector with an x, y, and z component. Another common way of representing vectors is to use something called the standard basis vectors I, j, and k. We can visualize these vectors in 3 dimensions. If we plot a 3D coordinate system, using the right-hand rule, we have the x-axis, the y-axis, and the z-axis. The vector I goes a distance of 1 only in the x direction. This would be I. The vector j goes a distance of 1 only in the y direction. This is the vector j. Finally, the vector k goes 1 only in the z direction. We can represent the same vector using these two different pieces of notation. Two vectors are called parallel if one vector is a scalar multiple of the other. Let's talk about how to find magnitude. The magnitude or length of a vector can be found using this formula. We represent the magnitude using these vertical bars, which look like absolute value bars, and the magnitude is equal to the square root of the sum of the components squared. We could find magnitudes of two-dimensional or three-dimensional vectors. Let's try this example. The magnitude of the vector 2, negative 5 is the square root of 2 squared plus negative 5 squared. If we simplify, 2 squared is 4, negative 5 squared is 25, so we have the square root of 29. That is the length of the vector 2, negative 5. In 3 dimensions, we have the same notion, we just add in the third component squared. We have the square root of 3 squared, which is 9, plus negative 2 squared, which is 4, plus 6 squared, which is 36. 36 plus 4 is 40, 40 plus 9 is 49, so we have the square root of 49, which is equal to 7. So this vector has a magnitude or a length of 7. A unit vector is any vector that has a magnitude of 1, and we can find a unit vector in the direction of any given vector using the following expression. If we're given some vector v, then to find a vector of distance 1 in the same direction as v, we simply multiply by 1 over the magnitude, or we can think of dividing every component by the magnitude. For example, let's find the unit vector in the direction of this vector 3, negative 2, 6. We just found that the magnitude of this vector is 5. So in order to find the unit vector, we divide each component by 5. This is 3 over 5, negative 2 over 5, and 6 over 5. This new vector has a magnitude of 1, but it's in the same direction as the vector 3, negative 2, 6. Let's take a look at this in GeoGebra. Three divided by 5, negative 2 divided by 5, and 6 divided by 5. We see a vector in the same direction as the original one, but it has a magnitude now of 1. That is a unit vector.